is Ms. DB. In this video we are going to look at graphing radical functions. So a radical is a square root or a cubed root or a fourth root and so on. If there's no number inside of the radical right here, that's called the index. If there's no number there, it's a square root. You could think of there being a little 2 there, but you don't have to have a little 2 there because we've accepted that that means square root. So what we're going to do is graph these, find the domain and range. We're going to transform them or say what the transformations are and answer some questions about these. You can do graphing of cubed root and fourth root and other ones as well. It's a little more complicated. In this assignment, we're just going to look at graphing square root functions. In your textbook, you can see graphing cubed root, and that's actually the honors assignment for this week, is graphing cubed root functions. All right, so again, we call this a radical function or a square root function. If the parent function is just f of x equals the square root of x, like we have here, that's the parent function. There's been no transformations. The domain of this is positive numbers, so x has to be greater than or equal to 0. We wouldn't want a negative number underneath the radical because then you would get a number, a complex number that is not a real number. So we're only going to deal with real numbers here. The range is also y is greater than or equal to 0 because since you're not using any negatives, you'll never get a negative y value. Now, your domain and range will change depending on how your function has been changed from the parent function. So here's an example. This is f of x equals the square root of x plus 3. So it has been changed. Look at, here's the graph of it. You can see that from here, it's moved left 1, 2, 3 units. So the transformation would be a translation left 3. The domain of this function is that x would have to be greater than or equal to negative 3. And the range stays at y is greater than or equal to 0 because this one did not move up or down. Sometimes if they move up or down, then the range changes too. To graph these by hand, you can plug in different values for x and then simplify this expression and see what you get for f of x, which is the same as what you'd get for y if you called it y equals square root of x plus 3. So you want to pick values of x that will simplify so that you can take the square root of them, so perfect squares. So the first one I did was negative 3 because that would make this 0. So f of negative 3 means I'd plug negative 3 in for x. So negative 3 plus 3 is 0. The square root of 0 is 0. So here's our first point, negative 3, 0. And there's that point right there in the graph, negative 3, 0. Then I picked another one that would give me the square root of 1 because the square root of 1 is 1. So negative 2 plus 3 is 1. Square root of 1 is 1. So there's another point, negative 2, 1. And then at 1, x equals 1. See, I didn't put negative 1 and 0 and all these other numbers that would give me a decimal or a square root that can't be simplified. But 1 plus 3 is 4, so the square root of 4 is 2. So I have a point at 1, 2. And then try to pick at least one more. 6 because 6 plus 3 is 9, square root of 9 is 3. So you're kind of thinking ahead when you pick your x values. And there's the point 6, 3. And then you make a smooth curve through the points like that. Now, if you want, when you do the next couple of problems, you can graph them by hand like that. Or you can, after you make your table, you can use Desmos or Sketchpad to make your graph and then put a screenshot here. Here's a review of the transformations. We're only going to be doing translations and reflections on this worksheet, not vertical or horizontal stretches or compressions. So vertical translations, you will be adding or subtracting a number at the end after your square root, not inside of the square root. That will either move it up if it's a positive or down if it's a negative. Horizontal translations are added or subtracted to the x underneath the radical sign. If it's minus h, it moves it to the right. If it's plus h, it moves it to the left. And then reflections, if the negative sign is in front of the square root, it's reflected across the x-axis. If it's underneath the radical with the x, like in this one, it's reflected across the y-axis. So you can use these rules to help you determine what the translation or reflection is. But you can also look at your graph and also graph the parent function and see if it moved left, right, up, or down, and or if it was reflected over the x or y axis. Some of these only have one transformation, but several of them have two. So here's the first one, says the square root of x minus 2. So you're going to, I picked values for you that would work out nicely so that you'll get integer values over here, and then you can plot those points and see, and then connect them with the smooth kind of curve. Square root functions increase very gradually, and they almost flatten out. There's no asymptotes to follow. They just are going to keep increasing gradually if you were to keep graphing this out. And they start at a point, they have an endpoint, they don't continue in both directions. Don't forget to add the domain and range. In number 2, you're going to do this for negative square root of x. Again, I picked some values for you. Let's look at one where there's no table for you, but I'm going to make a table just because. Let's see, which one should we do? Let's do number 5. Actually, we'll start 3 and then we'll start 5. Okay, so I'm going to insert a table so I can get some points so I can practice. All right, so I need some x. Oh, I could have made my table the same way as theirs, I guess. Okay, so you want some x values and some f of x values, and then you can, actually I'll add one more row here. So the middle one is where I could do my work. So I'm going to graph this. I'm just going to copy it and put it here. I guess it's s of x, not f of x. All right, so we're going to pick some values of x. This is taking the square root of x, so I'm going to pick ones that are perfect squares. So square root of 0, square root of 1, square root of 4, and I'll do the square root of 9. And the reason I'm picking these values is because now when I plug in the square root of 0, that's just 0 plus 3 is 3. So now I have that value. And for the square root of 1 plus 3, that would be 1 plus 3. And 1 plus 3 is 4. And then I have the square root of 4 plus 3. That would be 2 plus 3. So that would give me 5. And then I have the square root of 9 plus 3. And that would be square root of 9 is 3. 3 plus 3 is 6. And then to graph this, let me get a graph. Just copy this one. You can graph these by hand, and I would just put the points. I'm going to, you could use your pen tool, or you can go to insert shapes, and you can just add little points here. So I need a point at 0, 3. There's a point, and I'm going to copy that point and paste another one at 1, 4. So here's 1, and I have to go up to 4. That's good enough. And then I need another one at 4, 5. So it's not linear, it's going to curve. Come on, it won't let me go at 5. There we go. And then I need another one at 9, 6. So over to 9 and up to 6. So there's my points. This one's a little low. And then you want a smooth curve through that. So if you don't have a pen tool like I do, you can go to insert shapes and find a squiggly line I want the one that says that I can kind of do what I want to it. Maybe it's this one, freeform scribble. So I'm going to start at that point, and then I'm just using my mouse to draw that. And it would go like that. So pretty much like that. And then it says, using the graph of f of x equals the square root of x, that is your parent function, which was right here. Oops, not that one, this one. So how has this one been changed? It has moved up because the parent function, let me draw that again. Scribble. The parent function starts at 0, 0, and at 4 it's at 2, and at 9 it's at 3. So it's like this. It's just like that, but lower. So that can help you see that the translation is up 3. What's the domain? Well, it can't have any x values that are negative. So that means that x has to be greater than or equal to 0. The range. My range is not just greater than or equal to 0 because I'm not going to have any values less than this first one, which was 3. So my range would be y is greater than or equal to 3. Underlined a little too far. And that's how you do these problems. Now you don't have to attach your graph, but you should probably make the graph so that you can help determine what the domain, range, and transformation are. I said I'd also start number, did I say 5? I think I said 6. So in number 6, let's look at Desmos for this one. All right, so I have Desmos over here. All right, in Desmos, I can graph this square root of x minus 4. How do I graph the square root of x minus 4? Let's look at our keypad in Desmos, and I'm going to try to get this to go up a little bit. Because the keypad is, the square root key is at the bottom, right below the less than or equal to. Okay, keypad, here's the square root. So you are going to want to do the square root of x minus 4. So here's the graph. Make sure that your view here shows what's going on with your graph so that you can actually see what's happening. I think I'm going to graph the square root of x as well so I can see how the transformation, what the transformation has done. So the square root of x is the blue one. It looks like the red one, the square root of x minus 4, is moved over to the right 4 units. So for the transformation, you would say, oh, it's this one. You would say translation 4 units to the right. And the domain, now we're looking, I'm going to hide the blue one so I don't get distracted. The domain does not start at 0 for this one. The domain starts, the lowest x value you can have is 4. So for the domain, you say that x is greater than, and you can just underline the greater than sign to show greater than or equal to 4. The range, the lowest value the range can be for the y value is 0. So you'll say that the range is y is greater than or equal to 0. All right, the next part you're going to write a function that has had these things happen, and you can check them by graphing. So let's turn this one off and turn this one back on. So I have the parent function, the square root of x. It's reflected across the x-axis and translated 3 units down. Let's go see what happens to make it reflected across the x-axis. Reflections across the x-axis, I need a negative in front. So let's put a negative in front, and then the square root of x. Yep, that reflected it over the x-axis. And then I also needed to go 3 units down, I think. Let's see. 3 units down. So if I want to move that green line down, how do I translate it down 3? Where do I put my 3? Do I go minus 3 at the end? or do I do plus or minus inside the radical? Let's see. If I put minus 3 right now, nope, that moved it to the right. That wasn't right. What if I put plus 3 inside there? Nope, that moved it to the left. So I'm going to use my arrow key and get out of the radical, and then put a minus 3. That moved it down. So this is my function. I can put my function notation in front of it so it looks more like a function. So g of x equals to negative square root of x minus 3, and that's what I need to write for that problem. G of x equals, so for square root you can just write sqrt x and then minus 3, or you can get the square root symbol, insert symbols, and there's a square root symbol, square root of x, and if you wanted it to be the square root of x minus 3 all under the radical, you would need to put parentheses around it, like this. That's not what I want for this one, but if there is one that you needed a horizontal translation, left or right, then put parentheses around it. Or maybe we should just put parentheses around the x, because that's the only thing we want to take the square root of x. It's just trickier to write it. If you're writing it by hand, it's much easier. You can just write square root of x, and it's very clear that only the x is under the radical, and then the minus 3 is after. And then number 8 is the same way. And then 9 and 10, you're just going to discuss whether or not these radical functions have asymptote and symmetry. And you can maybe look back at the take another look at a radical function assignment, and that my response to that might make you remember whether or not they have those. All right, thank you very much. Have a wonderful day.